Daniel Kleppner loves precision, building precise woodwork, theories, and instruments. And because of his insights and inventions, astronomers can peer deep into the universe. Global positioning systems, GPS, navigate us where we want to go, and a new world of quantum computing is emerging. He began the search for Bose-Einstein condensates, chilling atoms enough to cause quantum mechanical mischief. But when he started his career, Kleppner had no idea that his precision research in physics would revolutionize the world. Kleppner was born in New York City in 1932. In high school,
physicists were heroes because of the atomic project and because of the development of radar. It was an easy era in which to become delighted by physics, and I was.
After starting at Williams College, he moved to England to study physics at Cambridge University.
That was a wonderful period in my life. I met my wife there.
He did his graduate, postdoctoral, and junior faculty work at Harvard and moved to MIT in 1966. He became fascinated by Einstein's theory of general relativity as an undergraduate.
When I first heard the idea that gravity could change time, it seemed to me totally extraordinary. We really don't have that much intuition about time. Time just flows by. We can't do much about it. So there's always something strange and slightly mystical about time.
Kleppner and his graduate school mentor Norman Ramsey wanted to see Einstein's gravity effect on time using clocks in the laboratory.
The effect is not very large. It's about a second in a billion years, roughly. So a clock that good has to be very, very good.
5 years later, they patented that very, very good clock, the hydrogen maser. The maser not only proved Franklin medalist Einstein's theory, but allowed the implementation of satellite-based systems like GPS and the Internet. Plus,
hydrogen masers made it possible to do very, very high-resolution radio astronomy.
Kleppner realized that increasing the size of a measuring tool was not the only way to increase precision. To measure energy, he found a way to lengthen the time available to make the measurement. When atoms absorb energy, they do it in stepped or quantized amounts.
And if the atoms are in the ground state, they just stay there. But if they are in one of these upper states, they're going to spontaneously radiate to the ground state.
This is called spontaneous emission, and if it happens too quickly, any energy measurement would be inaccurate.
The idea came to me, suppose we could prevent it from radiating.
He decided to put the atoms into a two-sided box, or cavity. The shiny walls reflect electromagnetic waves radiating from the atoms. But
if the cavity is smaller than the wavelength that the atom wants to radiate, it couldn't radiate.
He termed it inhibited spontaneous emission. Lacking a really small box, he needed a really big atom to test the idea. Fortunately, he could make one, a Rydberg atom with a very energetic electron.
A Rydberg atom is enormous. There's a proton sitting here and an electron sitting there.
Kleppner built a working apparatus, starting the field of cavity quantum electrodynamics. CQED is an extension of quantum mechanics. It provides important insights into how to build super-fast quantum computers, a technology that will be as revolutionary as today's silicon-based computers. Another way to measure quantum effects is to chill atoms. Jyotirndra Bose and Albert Einstein predicted in 1925 that if a dense bunch of atoms were cold enough, they would condense into a new form of matter.
When we started work on Bose-Einstein condensation, no one was really thinking about it at all, or virtually no one.
Nobody knew how to cool materials enough. When Kleppner found a series of clever ways to approach the problem, other scientists jumped in. Ultra-cold atoms
really became quite hot.
Kleppner spent his career at the center of the quantum physics community.
I can't separate my own career from the work of my students and the community in which I live. I'd say my career is trying to be a good citizen in the world of physics. Well, you do have to be clever to think of things which are very simple. As you get cleverer, things get simpler. But when you get down to it, there's no substitute for being clever.
The 2014 Benjamin Franklin Medal in Physics is presented to Daniel Kleppner.